Alright, hello everyone, welcome back again to my channel. My name is Hardefa Rogonondo, and today we will talk about the project for deep learning courses from Pacmann. And the title of this project is IMDb Sentiment Analysis Engine. Let's go right to it. Alright, the content of this presentation will be the number one is the deep learning and sentiment analysis, where we see the role of deep learning in interpreting emotions and opinions from textual data. And the second one is the long short-term memory networks, or LSTM, where we see the mechanism of LSTM in capturing long-term dependencies in sequential data for sentiment analysis. And the number three is this implementation and experimentation, where we applicating LSTMs to sentiment analysis and review the experimental results. And the last is the conclusions and future works, where we see the summary and future enhancement plans. All right, let's go to number one, where we see the deep learning in sentiment analysis. Well, what is deep learning? Well, actually, deep learning is inspired from mimics the way that our brains process the data using artificial neural networks. And deep learning itself is kind of layered learning where they utilize layers of algorithms called neurons to learn from vast amounts of data. And well, deep learning can be used for y- solving complex decision making where it's excelling in tasks like image and speech recognition or by recognizing integrate pattern. And the next is what is sentiment analysis? Well, sentiment analysis is kind of emotion detection where it analyzes text to determine the writer's sentiment, whether it's positive, negative, or even neutral. Well, the applications is widely used in monitoring brand reputation, market research, and public opinion. And the data source is so varied, examines like various texts, or maybe including social media posts, reviews, and blogs. Well, deep learning in sentiment analysis. Well, actually, deep learning elevates sentiment analysis by accurately interpreting nuance and context in the text, allowing for detections of emotions, including subtle tones like sarcasm, and this enhances the precision in gauging public opinion and monitoring the brand sentiment, making it a powerful tool for understanding complex human emotions in large dataset. Well, you might be wondering what's those picture above, but well, we'll talk about it later after this. Let's talk about long short-term memory networks, or we can call it LSTM. Well, what is LSTMs? LSTM is kind of advanced RNN, or recurrent neural network, capable of learning long-term dependencies in sequential data, important for tasks like sentiment analysis, of course. And it solves vanishing gradient. Well, it's specially designed to avoid the common issue in traditional RNNs, where importantly, early informations get lost over time by selectively keeping and discarding information, ensuring that vital details are remembered throughout the sequence. Well, you might be wondering how can such a algorithm forget and remember such things or maybe important things. Well, we'll talk about it right after this. And LLCMs have been used in many applications, requiring understanding of context and sequences, such as language translations, speech recognitions, and sentiment analysis. Well, this is the architecture of LSTMs. Well, LSTM itself has a unique structure. They are composed of a series of repeating modules called cells. It's designed to remember and transmit information throughout the network. And in LSTM, we have several gates. Like the first one is its input gate, where we determine new information will be added to the cell state. And its oracles have the forget gate. It decides what information is discarded from the cell state, helping the network to forget the irrelevant data. And we, of course, have the output gate. Well, it controls the information from the cell state and will be used to generate the output of the current step. Well, you might be wondering what is the cell state? Well, the cell state itself is kind of conveyor belt that runs straight down the entire chain with only minor linear interactions. It's the mechanism of LSTMs used to carry information across the sequence. The gates regulate what information is added and removed from the cell state. So it's kind of like running all those uh, formula almost at the same time. So the cell state can know or understand which one is the information that we should keep and which one is the information that we should forget. And LSTM in our projects, where in our project we use LSTM in our hidden layer. Well, from the first one, before we go to the LSTM part, we need to pre-process the data. We combine like tokenization, like lemmatization and stemming, and cleaning to refine the text data for model readiness. And then we go to the dense embedding, uh, where it's a conversion into dense vector that capture the semantic meaning of words, allowing the model to understand the text numerically. So as we know that machine learning or deep learning model don't know what really the text is, but we can dense or we can convert those texts into numerical objects. So the we can give the process data into the LSTM layer. Well, the model will analyze the data sequence and taking into account the context and dependencies of the word. And the last part is the results of the LSTM layer, where we get the two sentiments, whether it's positive or negative. Now it's the implementation and experimentations. Well, before we see the end results, we actually have to see the data. We have to do the exploratory analysis. And the bar chart above illustrates the distribution of sentiment labels in our dataset, showing a nearly equal number of positive and negative reviews. This balance is crucial as it allows our LSTM model to learn without bias towards a particular sentiment, ensuring robust performance when predicting the emotional tone of new reviews. And the other one is the word cloud represents the most common word found in the movie reviews. The prominent word like movie, story, character reflects the key aspects that viewers frequently discuss. The larger word, the more it appears in the dataset, indicating the common themes and topics within the review. And this is the baseline model performance review. From both conversion matrix, the train and test, indicates a high level of accuracy, with a significant measure of both positive and negative sentiments correctly identified. Notably, the ROC curve shows a perfect area of the AUC or under the curve of 1 for the training set, contrasting with a still excellent but kind of lower of 0.94 for the test set. This points toward a potential overfitting, where the model may be too closely tailored to the training data, thus capturing noise along with the underlying pattern. And this is the Hypertune model performance review. In the updated conversion matrices and ROC curve, they demonstrate a more balanced outcome compared to the baseline. While the training sets ROC, AO, and AUC has slightly decreased from perfect 1, it was still excellent, like 0.98. This reduction signals a desirable decrease in overfitting. The test ROC AUC remains robust at 0.94, mirroring the baseline model's ability to predict sentiment accurately. Well, this is the demonstration of the project that we have done. Well, you can put your text over there and then click predict, and then you got the predicted sentiment. You can also like try another text you want, and then just press the button predict, and you get the predicted sentiment given from the model. All right, let's go to the conclusions and future works. Well, the conclusion is the first one is the we demonstrated effective use of LSTM networks to analyze and predict sentiment within the EMDB review dataset. We utilize a crawl dataset from EMDB, providing a rich source of user-generated content for analysis. And end-to-end solutions, we develop a user-friendly front-end and coupled with a robust backend system, facilitating a seamless interactions with the model. And we achieve the project containerization, enhancing the portability and easing the development process across different computing environments. And the future works, we can investigate more complex models like bidirectional LSTMs or maybe transformer-based architecture like BERT for potentially higher accuracy. We can also incorporate a larger and more diverse dataset, including reviews from other language or platforms to improve the model's robustness. We can also integrate additional textual features from the user ratings, temporal data on review timings, and metadata from movies to enhance predictive performance. We can also try to shift from binary, like the positive or negative, to multi-class sentiment analysis to capture the spectrum of emotions. And the next one, we can develop capabilities for real-time sentiment analysis to provide instant feedback. And the last but not least, we can adapt and continue customize the model for sentiment analysis in different domains such as product reviews, social media monitoring, or customer feedback across various industries. Well, thank you for listening. This is the link for the project of this course. Well, if you have any questions, feel free to ask. See you in the next video. Bye bye. Thank you.